Welcome to the fifth module of the course. Today we will have a look at different ways of executing Python code, and we will have a first look at Jupyter, which you will see a lot during the next modules of this course. Enjoy! We will start with looking at different ways of executing Python code. To my knowledge, there are at least 4 different ways of doing this, of which 2 I personally use regularly, and 2 are just stuff that you need to know about. So the first way would be to simply pass a file containing Python code to the interpreter. So let's say you have a file called main and it contains Python code. We will go into that in detail later. The second way would be you can pass Python code directly to the interpreter with a -c flag, and then in string signs you kind of write your code. And then you can separate lines with a colon and then write more code. We'll give an example of that in more detail later. Then there is Jupyter, which you should definitely check out. We will also do that a bit later. And then there is a fourth way, which is just using the Python interpreter and then executing code here, which I will also show in detail in a minute. The first thing we will have a look at is executing Python code directly. So Python 3 -c, and then we pass the code in this string here. So let's do it like this. Import OS. Colon separates individual lines of Python code. So what we do is we're importing the OS package, which is a pre-installed package that interfaces the operating system. And then we're going to use a function in this OS namespace with .uaccess functions of the package namespace or of, for example, objects. This function is called getEnv. And yeah, it's important that you use a different kind of string qualifier because you already used the string qualifier here. And then we are going to get the path variable. Separating off, and then we are going to print path. So again, what this does, it imports the package, uses the package, a function of the package. This function accesses the shell environment and gets us the variable path, and then we just print the variable to the console. This is a bit convoluted. You can do it easier by doing it the bash style, but of course then you can't process it within Python. So what you could do is you could use this variable to process it further. But you see, that's the exact same thing. It's just accessing it directly. So this way of executing code you will probably see fairly rarely. But you can use it very nicely in Python, in bash scripts. If you want to test simple things, for example, if a package is installed, Python 3 -c import TensorFlow. You see no module named TensorFlow simply because we did not install this package. And then you could do it in a bash script where you want to check if this is installed, and if it's not installed, you install it, for example. That's how I sometimes use this style of executing code. The next thing we will have a look at is using the Python interpreter directly. So you just type Python 3 and execute it. And here you can do the same thing, import OS. I'm just going to copy the code. And do print path. This style you will probably also rarely see because it's very manual and you have to type every line by itself. But for example, for demonstrating purpose, it's very useful, or if you want to quickly check something. The way you get out of here again is with Control D. Control D works for all shell, for all things in the shell. it detaches you from the process, so it gets you out of this interpreter, for example. The most common way to execute Python code is to write files and then pass them to the Python interpreter. But before we do that, we're going to set up a structure, a project structure, a little one, because I want you to get used to doing things in a very structured way. This is very important because programming is all about having good habits so that you do your stuff properly from the start. So we're going to create a source folder, and then we're going to create a main file in this folder, main.py. And then we're going to set up a virtual environment in our project folder, Python -m for module, venv for the venv module, and then venv is an argument to this venv module that just names the virtual environment venv. Oops. So now we have this virtual environment. We're going to source it, which is nothing else than activating the scripts in there. And now we're going to write our first file. We already created the file, so now we're just going to code in it. So in Python, you separate your code by lines, as you saw earlier, but I didn't explain it in detail there. So what you would do is you would start with the imports. They are always at the head of your files. And then you execute your code. Path is equal to os.getEnv. I'm used to programming on a German keyboard with the English layout. That's why now with my English keyboard I'm kind of messing up the brackets all the time. So path, and then we're going to print this again, print path. Escape, right quit, and now we're going to execute this file. And you see, the same thing as before happens. The only difference is that the virtual environment we created has kind of snuck up here in the path variable. If you're using this file-based approach, it's very smart to structure your project from the start. So I'm going to show you how to do that. So we have this main file here. And this will be the file that we execute in the project folder with Python. So what we're always doing is we will do Python 3 src main. And this will, this is now empty. I just emptied it. That's why nothing happens here. But this is how we will always call our Python app, so to speak. So this will always be the entry point, this main file. And in the source code folder, we will now create a package where we will actually hide all our code. So in this main file, we will just import the code that we write, and then we'll use the main file to execute it. So in order to create a package, you're going to create a folder. In this folder, to make this recognizable as a Python package, we need to create a file called init. This essentially tells the Python interpreter this folder is actually a Python package containing Python code. And then we will create a file called app.py. This is where the actual code will go. So here we're going to do the same thing. Import OS. And then we will do path is equal to os.getEnv, getEnv. Path, and then we're using a format string for printing. F for format string from file app.py. Path is, can do \n for new line, and then in these brackets we can put variables. So if we could put the path variable here, what this f does, it actually converts whatever is in curly brackets, so variables that you put in here, it will convert them into a string and then build the string and then pass the string to the print function and it will be printed. So if we now execute this file, python3 app.py, you will see it will just print what we just put in there. And it will say from file app.py, the path is blah, blah, blah. So now, when we rewrite our main function, here we will just import this. Say we're interested in this path variable. We're going to say, actually, from my app, so from this folder, .app, there is a file in this folder called app, and from this file we want to import a variable path. So whatever you import can be a variable or a function or a class. We will do a complete video on the Python objects in more detail later. So what we're going to do now is we're going to print this. Again, a format string from main.py. Path is /newline and then the variable in brackets. Then we go back to our project folder and here we will say python3 source main. Now you see it's actually printed twice, and this might be a bit surprising to you, but I can explain why. So let's have a look in this file again. Main. Importing Python files actually executes the file executes those files as if they were a script. So the print statement that is in the other file, so in my app.py, this here will be executed. So it literally does import path is and then prints this. If you want to prevent this, you have to put a kind of guard around this. So if you still want to be able to execute this file standalone as detached from the package, so if you want to keep this print statement, so to say, what you have to do is you have to do something like this. Name So you might see this very often. This is sometimes at the bottom of files. So if you want your code only to be executed if you directly use the interpreter to call this file, then you can hide it like this. So if we now go back and do python3 source main, you see I have a syntax error. Source, what did I call it? My app. And again, python3 source main. So now you see it's only printed once, and this is from the main.py file. So this is how you write your own module files and how to make your code reusable by hiding it in different files. Because now you can take this app file and put it in another project, for example, very easily. Just a small addition, I forgot to prove that this actually still works. So let's say python3 source my app. So if we now execute this file, it actually executes this print statement. So you will see these type of sort of include guards all the time in Python projects. So you see the difference. If I execute the file directly, it uses the print statement from there. And if I did what I did earlier, it would, without this guard, you would have to, you would execute this code twice, essentially. The last way I want to show you on how to execute Python code is with Jupyter notebooks. This is the way I always work in Python, and I strongly suggest that you kind of go in this direction as well, because Jupyter makes it very easy to figure out if your code actually does what you think it does. And it's just gonna speed up your workflow immensely, because debugging in Jupyter is very easy, and it forces you to work in very small units of codes. So the way you get started is just by doing pip3 install Jupyter. I already did this, that's why this is going to be very quick. And then you can start a notebook by typing Jupyter notebook. What this does, this starts a Jupyter server in your browser and also brings you directly to the browser where this is. So the browser pops up. Let me just move the window so you can see it properly. You create a new file just with new file. You can name the file here. Let's call this test Jupyter. And before we even start, the most important thing you need to know is one shortcut, that is Control M, and then pressing B multiple times adds cells. So the way you work in Jupyter is you code in these cells, and then with Shift Enter you execute a cell. So for example, what you do here is you type your Python code here, import os, path is equal to os.getEnv, path. And then you can do print path. And then Shift Enter will execute this and also print to the console. So here you see the path. And now you could just copy and paste this code into files and build a Python package from that, or your Python application. This is very convenient because now everything that you executed here is globally available. So you can access the path variable here. So you can just do print path, and it will print the path variable. So whatever you executed in this cell will be available in the next cell. And also the order of cells relative to each other does not matter. Another neat thing is you can just print by just executing the variable, so to speak. And this is where you see this becomes really, really strong, because most of the time, if you're working on, say, data science tasks or anything, you have to have a look on how these variables actually, how they look, because most of the bugs that you create will be because you don't know that an array of an array of an array of an array actually contains a dictionary and not a number, for example. So by simply being able to print this stuff so easily and quickly here, you can come up with writing small chunks of code that work, and then move yourself through the code, and then copy together larger cells of stuff where you're sure this works and this does what you think it does. So this is a very easy and convenient way to execute Python code. Another very cool feature of this is you can actually execute bash code here. So what you can do is you can do echo hello. So by putting this exclamation mark in front, you tell it that this is actually bash code. So you can also do this prints the path variable. So this is a bash variable, and this is a bash program. And just with the exclamation mark, you can execute whatever bash code you want in here. And another really cool thing is you can mix things. So work here is equal to os.getEnv, let's say pvd, so print working directory. work dir. Here you can pick what type of cell you want. I leave that to yourself to explore this. So if you want to see what work dir is, some reason I'm mixing up code and markdown here. So this is a string that tells us what the name of this directory that we're currently in is. And now comes the cool part. You can mix Bash and Python. So you could do some very complex Python calculations or whatever, and then pass that to another program in Bash if you wanted to. Or you do that by just doing it like this. So this is the most convenient way to actually develop code in Python, I think, because these cells encourage you to write very small parts of code, execute them, and then see what happens. And then once you know what your code actually does, you can continue in the next cell to develop kind of your program. And once you're done and happy with everything, you can copy it out and put it in Python files, and then build larger things from it. This is a very, very fast way of developing code. If you compare this, for example, to developing in C++, where you first have to compile your code, put in logging statements and console printing statements to actually see what it does. And if it does what you think it does, you're like 20 times faster in developing code in here. And this is one of the big strengths of Python. Thank you very much for watching. See you next time.